Hello, everyone. Happy Friday, ladies and gentlemen. It's the Screencast. It's Master Should Know. And today we are talking about box plot. Those of you that are old enough to remember things like Josie and the Pussycats being a cartoon, or maybe Scooby-Doo being a cartoon, will probably remember us calling this word right here, not box plot, but box and whisker plot. But ladies and gentlemen, the modern way of saying it is just box plot. Today we talked in class about how to find outliers, and that was a complete review because we covered that in another screencast when we talked about finding outliers. Today we reviewed how to find median, quartile 3, quartile 1, and interquartile range and all those sort of things. Please feel free to come and talk to me about that if you do have a question about that today. But what we want to do is make a box plot. And it's just a way of showing, organizing our data and showing something about that data. Here we go. Here's a problem, and we can definitely talk about. It's the measurement of a whole bunch of car speeds. And if we want to represent this as in some sort of array of data, we could use a box plot to do that. And the first thing we need to do is put our numbers from least to greatest, find Q1, find Q3, find our interquartile range, multiply times 1.5, go ahead and find an outlier, and pretty soon we'll have everything we need for making a box plot. First of all, I think where I start is here, the median. The median of this data up here is 25. Q1 is 22, represented by this dot right here. Q3 is 34. It's represented by that dot right there. And these extremes over here and here are the smallest and largest number in our data set. So apparently our smallest number was 19. Yep, there it is. And our largest number was 40. Now I can take that information and change it into a box plot. There it is. The line in the middle of the box, that's our median. Here's Q1, here's Q3. That's our smallest number. That's our largest number. If we did have an outlier, well, then you would see like a little star and asterisk. Let's just pretend 51 was one of our numbers and it didn't fit in. Might have been an outlier. You'd see a star in that case. What does this tell me? Well, it tells me, first of all, that from this dot here to Q1, to there, to there, to there, each one of those jumps represents 25% of all the data up here. So I could say from here to here is 25, from there to there is 25, from there to there is 25, and there to there is 20. That's important because that will help us with finding some of our statistical data that we need. Let's clear this off. Okay. Looking back at that box plot, it does tell me one thing. First of all, it tells me a lot. It tells me that 25 is the median. It tells me that 40 is my biggest number. It tells me that 19 is my smallest number. But one thing that it does tell me is like this data, when it is all spread out, isn't symmetric. It doesn't come out kind of evenly, and that the median is trending down towards Q1, and there's a lot more space, or the numbers are spread out a lot more between the median and, say, 40, our largest number. Ladies and gentlemen, those are box plots. We did make them today in class. I'll probably be working on those a little bit on Monday. If you have any questions, feel free to give me an email. Our email is at markschattler@pennmanor.net. Also, I do appreciate people commenting on the blog site. Ladies and gentlemen, those are box plots, and that is the maths you should know.